Welcome to the Introduction to Cloud Computing. In Lab 1, we will provide you with an introduction to cloud computing. These are the main contents that we will be discussing in this lab. We will go over the goal of this lab, the evolution of the cloud, growth of cloud computing. We will take a look at what is a cloud system. Here we will discuss in detail the different types of cloud, its characteristics, and also different types of cloud service providers. This will be followed by a few slides, and that will introduce you to OpenStack. We will discuss what OpenStack is all about, and then scaling, which deals with the number of users accessing the resources. And finally, a summary on OpenStack and Chameleon and their services. There are no prerequisites for this class. The objective of this lab is to provide an introduction to OpenStack and cloud computing. Cloud computing gradually evolved from mainframe computing, which worked on a shared resource model. The internet has an important contribution towards the evolution of cloud computing. With its advent and increased reliability, as well as low cost of internet access and computers, there has been an improvement in the use of and number of web-based applications. The evolution of cloud computing can be briefly explained using the following. Grid computing. This involved usage of a distributed architecture working on a single problem, and the tasks are assigned independent of each other. Utility computing. In the case of utility computing, the resources required for computing are made available to the client as a metered service. SaaS, otherwise known as Software as a Service, is a network-based model that takes care of software licensing and delivery by providing applications through a web browser. And cloud computing. This provides the required computing resources anytime, anywhere for the clients. Growth of the cloud. One of the first milestones with cloud computing was with Salesforce.com, which delivered enterprise applications through a website. Cloud computing brought in a lot of activities that ranged from replacement of on-premise infrastructure to on-demand applications. The four main areas that cloud computing focused were virtualization. In virtualization, it deals with multiple pseudo servers on one physical device. Having multiple virtual servers instead of a single physical server with segregated data is the backbone of cloud computing. It promoted better flexibility and resource utilization, thereby improving efficiency. Democratization of computing. Cloud computing has facilitated business development to a great extent. Democratization has enabled setting up of an infrastructure and application for a particular business in an effortless manner. With cloud computing, it provides a centralized access to the common business and web applications that are required for the client's use. It also allows to massively scale the infrastructure to a level that were not attained previously. Scalability and fast provisioning. Under provisioning and over-provisioning of servers are scenarios that can create an undesirable impact on the business or its service levels. Cloud computing allows businesses to maintain their infrastructure levels as and when required. Commoditization of infrastructure. Cloud computing allows the IT users to use the resources as and when required, allowing them to focus on the important aspects of their roles. There has been a rapid growth in the cloud computing market. The following graph shows the number of websites that use cloud providers. The graph has the websites and their respective growth values denoted in the axes. The definition of cloud computing according to the National Institute of Standards and Technology is as follows. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Ergo, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. In simple terms, it is storing and accessing data and/or computing resources over the internet. What is a cloud system? The cloud system is based on the internet. It is an internet-based computation. You get access to your data anywhere, anytime using the cloud. Cloud computing is a service model that consists of shared configurable computing resources that can be accessed through your network. A cloud computing stack consists of software, platform, and infrastructure. It is massive data processing, and it is easy to access your programs, any data, the server itself, databases over the internet, or is in sync with other information on the web. The main types of cloud include public cloud, private cloud, community cloud, which is a shared cloud shared by more than one organization that shares common cloud requirements, and then a hybrid cloud, which is a mixture. A public cloud can be accessed by any client with access to the internet and to the cloud space. There is much cost savings with public cloud as there are no upfront costs or infrastructure costs that usually come up in the case of an on-premise setup. The users and or clients have increased flexibility with public cloud as it allows capacity to be mapped adjacently with the requirements. The public cloud is based on a virtually unlimited capacity whenever the client requires it. A private cloud is for a particular group or organization, and the access rights are given only to this group. Private cloud is either managed by the organization itself or by a third party, and it exists either on premises or off. This diagram shows the four approaches of a private cloud. Private clouds help organizations better fulfill their needs for a more precise or secure physical or logical separation of data from other organizations. It also provides ways to improve efficiency on the existing infrastructure that the client uses. Private clouds also help to meet specific technology requirements other clients might have. And as well, it helps reduce risks that are associated with vendor lock-in. A hybrid cloud is a combination of at least two clouds, where the combination includes public, private, and or community. Hybrid cloud provides the flexibility to retain a part of the infrastructure while moving others to the cloud. It allows workloads to be split between existing infrastructure, and the cloud hybrid could also allow the workload to be retained both on-premise and off. The five main characteristics of cloud computing include on-demand self-service. This is auto-provisioning of computer resources as and when needed without any human intervention. Broad network access. This is computing resources that can be accessed anywhere using the internet. Resource pooling. Dynamic assignment of resources in order to meet the requirements of the consumers. Rapid elasticity. The resources are released or assigned on demand. Measures service. The client only pays for the computing resources that were used. Cloud providers are called cloud service providers, or CSPs. A cloud provider is a service provider that helps with a specific functionality and or service. The service provider is chosen depending on your requirements. It depends on the way the computing resources in the cloud are used or accessed. There are three types of cloud providers. Software as a service, or SaaS. The SaaS provider provides access to the computing resources and applications for the end user. By accessing the cloud, the client gets to access software and other similar applications. SaaS provides the least control over the cloud. Platform as a service, PaaS, is a service setup. The service provider provides components required for development and operation of applications in a quick and efficient way. This tends to be marketed more towards development purposes and was started by Google. Infrastructure as a service is the maximum control over the cloud resources. The complete infrastructure that are required for the organization is outsourced in IaaS, and that is the hardware and software like server storage, networking, and operating systems. The SaaS, or software as a service provider, provides access to computing resources and applications for the end user. It is a fast-growing technology. By accessing the cloud, the clients get to access software and other similar applications over the cloud. SaaS provides the least control. Some characteristics of SaaS are the users get web access to commercial software. The software is made available to the users from a one-to-many mode type of software management. Software management, upgrades, and patches are handled by the service provider from a centralized location. Applications of software as a service involves an interplay between client, organization, and outside world. There are many organizations that require web or mobile access to software without necessarily having the more computationally robust parts of the software installed on the device at hand. Another application would be when an organization needs to be able to rapidly scale its business upwards or downwards due to external pressures, ergo tax software around tax season. PaaS generally benefits a software development world. It mixes both the simplicity of software as a service and the power of infrastructure as a service. PaaS acts as a service setup, providing a platform for creation of software, web applications, in a quick and an efficient manner. Here the client needn't bother about purchasing a platform to develop on, the maintenance of, or about the infrastructure that the software requires. This service provider provides components required for development and operation of applications in a quick and efficient way. Characteristics of PaaS. Services offered include those that are required to fulfill application development process. Processes like development, test, deploy, host, application maintenance, creation, modification, testing, and deploying are done using the user interface creation tools that are accessed through the web. PaaS allows concurrent access for multiple users on the same application resource. It integrates web services and databases using common standards. It provides project planning and communication solutions for development teams. It also provides the tools for billing and subscription management. PaaS is best suited for applications where accessibility for both developers and other parties in a development project is concerned. It is also used in cases where the testing and deployment services are automated. Some examples where PaaS is used include Google App Engine, Microsoft Azure Services, and Force.com. Infrastructure as a service handles on-demand delivery of cloud computing resources. IaaS has the maximum control over the cloud resources. Hardware and software infrastructure such as servers, network, storage, and operating systems that are required for the client are, in a manner of speaking, leased or rented. Infrastructure as a service can either be public or private, or a combination of both. A public cloud consists of shared computing resources deployed on a self-service interface via the web. In a private network, it focuses on virtualization, which is a cloud computing feature on a private network. For the characteristics, computing resources are considered as a distributed service. Dynamic scaling is allowed in IaaS. Pricing model used is a utility pricing model, which has variable costs. Multiple users have access on the hardware resource. Applications of IaaS include those which involve significant variations or control requirements with respect to the demand on the infrastructure, as well as for startup organizations that hardly have the capital to invest in the procurement of the hardware. IaaS also can be used in a scenario where the growth of the organization demands an increase in the hardware resources, or when the organization is pressured to change focus on the limit of capital expenditure to limit operating expenditures. This schematic shows the responsibilities of the cloud service providers. From left to right, these are examples of software as a service. The middle two columns represent platform as a service, and the far right is an example of infrastructure as a service. Let's take a look at some of the common applications of cloud. Software as a service, Microsoft Office Live, Dropbox, and Cloud Numbers. Platform as a service, Google App Engine, Salesforce, VMforce, and Joyent Accelerator. Infrastructure as a service, Amazon EC2, Eucalyptus Community Cloud, and IBM Cloudburst. OpenStack is a cloud operating system that controls large pools of compute, storage, and networking resources through a data center, all managed through a dashboard that gives administrators control while empowering their users to provision resources through a web interface. OpenStack can be considered as a group of software compute storage tools for cloud computing platforms. It mainly focuses on the development and management of public and private clouds. Here is a schematic representation of the cloud operating system. It helps to manage resources that includes pools of compute resources, storage resources, and networking resources to run applications provisioned to the clients. OpenStack has a modular architecture that includes components like the following: Nova, Swift, Cinder, Glance, Keystone, Horizon, Neutron, Ceilometer, Heat, Trove, and Sahara. Here we have the OpenStack conceptual architecture. The dashboard is Horizon. It is the only graphical user interface within OpenStack. The dashboard provides access and control to manage the cloud. Nova is the primary component for OpenStack with respect to computations. It takes care of the virtual machines and instances that handles computations by deploying and managing them. Cinder, the block storage component in OpenStack. Neutron. The Neutron module takes care of the networking in OpenStack by making sure that the components communicate efficiently and quickly. Glance. This is the OpenStack image service. It takes care of the disk and server images. The services include discovery, registration, and delivery services for the server and disk images. It can also be used as templates for the new resources like virtual machine instances that may be allocated. Swift acts as a storage for objects and files. This is also known as OpenStack's object storage, which provides a scalable system for storage. It provides a unique identifier to locate the objects and/or files, and the location of the storage is decided by OpenStack. Keystone is used for the authorization and authentication of OpenStack services. In short, it is the identity service for OpenStack. The services that it provides include identity, token, catalog, and policy services. Ceilometer and Heat are the telemetry services and the orchestration component of OpenStack, respectively. Ceilometer is a data collection service project that transforms and normalizes data across core OpenStack components. Heat allows developers to store the requirements of a cloud application in a file that defines what the resources are necessary for that application. In this way, it helps to manage infrastructure needed for the cloud service to run. These form the 9 key components that make the core of OpenStack. Massively scalable architecture in cloud computing has the ability to support more as well as disparate users than traditional serving model. The scalable architecture is a platform for a variety of workloads, especially for commercial and public clouds. As per the OpenStack.org tutorials, the services offered by massively scalable OpenStack include disk image library VMs, raw block storage, file or object storage, firewall functionality, load balancing functionality, private, non-routable, and public floating IP addresses, virtualized network topologies, software bundles, virtual compute resources. OpenStack is an open source software that provides an infrastructure as a service platform for deployment and management of private and public cloud. It caters to easy implementation and massive scalability for the cloud. OpenStack is configured as per the requirements of the client using the services offered. Key services offered by OpenStack include compute, object storage, and block storage, networking management, authentication, image service, billing service, cloud template, and the dashboard. Chameleon Cloud is an implementation of OpenStack with significant infrastructure differences compared to a standard implementation of OpenStack. The clientele for Chameleon Cloud is academic in origin for experimentation. It is reconfigurable because in order for it to be as similar as possible to having it in your own lab, it has bare metal reconfiguration, isolation, and support for repeatable and reproducible experiments. The scale of the operation is large, so as to accommodate big data and big compute research. It is connected because it partners with production clouds such as CERN, OSDC, Rackspace, Google, and others. Chameleon Cloud complements the GenAI, otherwise known as Global Environment for Network Innovations, Grid 5000, and other experimental testbeds. And then the follow-up would be Lab 2 for Keystone, Lab 3 for Glance, and Lab N, which means any labs remaining.